My name is James Kelly, and this is my overview of Lab 2, Charge Tape Revisited. Purpose. The purpose of this lab is to use two pieces of charge tape in order to observe the electric field between similarly charged items. We will experimentally determine the charge that a piece of tape holds by using a computational model which creates a string of point charges and calculates the net electric field. This will be compared to a previous experimental result using point charges to model the interactions between the tapes instead of a chain. For this lab, the main physics principles are Newton's second law, the force due to gravity, and Coulomb's law. Newton's second law is F equals ma, force due to gravity is F equals negative mg, and Coulomb's law, which is a method to calculate electrostatic force, is F equals kqq over r squared. As a reminder, the results of the previous experimental model showed that the piece of charged tape had a positive charge of 4.784 times 10 to the negative 9 coulombs. It was observed that the pieces of tape repel each other, but attract to a negatively charged plastic pen, meaning the tape had to hold a positive charge. Results of the computational model. This model showed that the charge of the tape had a charge of 1.94434 times 10 to the negative 4 coulombs. This is a significant increase from the experimental model previously used. On the right is a depiction of the printed out value from the computational model. Conditions of the experiment. The system is the top tape and the surroundings of the universe around it as well as the bottom tape. The initial conditions are the top tape at rest being held up at each end with only the initial force being applied being gravity. Contrary to the previous experiment, the tapes are modeled as chains of charged particles. This should allow for a much more accurate total charge calculation. This assumption of a chain of charged particles is simply more realistic, as this is how the tapes likely interact on an atomic level. Computational model. The computational model was created using a Python code which calculates the net electric field along a chain of identically charged particles. It starts by using the experimentally found charge of the tape and uses that as a charge for just one of the many particles on the chain. It then calculates the electric field due to every charge on the bottom chain and sums them up to create a net electric field for the entire chain. It then generates a visual depiction of the chain, the chains, the force due to gravity, and the net electric force from the bottom tape. On the left, the code shows the inputted constant values that are like the starting point, as well as a function which will apply Coulomb's law throughout the rest of the code. On the right, these are the main sections of code that will establish the two chains, the top and bottom chain of point charges. This final section of code will iteratively go through every single charge on the top tape and every single charge on the bottom tape and calculate the electric field location on the top tape due to the bottom tape for every single point charge. Discussion. Observed data of previous experiment versus computational model. The previous results were extremely different than the results of this new model. The original experiment showed a charge of 4.784 times 10 to the negative 9 coulombs. Comparing this to the computational model's results of 1.94434 times 10 to the negative 4 coulombs, there is an obvious difference. The computed charge of the tape is around 40,000 times stronger than the initial results. Sources of error. One key source of error is the fact that the two tapes were not the same. They had slightly different masses, lengths, and charges. It is also highly probable that there was not a uniform charge on the surface of the tapes, meaning that modeling them as chains of identical charges may not be entirely accurate. What this essentially means is that the computational results may not directly 100% apply to real-life observed results. Conclusions. If we had again modeled each of the tapes as a single point charge, what would happen? Well, essentially it would just give out the same results. It would only apply the point charge, it would only apply the Coulomb's law once and result in the same thing being a point charge model of 4.784 times 10 to the negative 9 coulombs. This is in contrast to the actually calculated value with the charged chain computational model of 1.94434 times 10 to the negative 4 coulombs. These estimates differ mainly because in the computational model, each and every point is being calculated against one another, meaning that every single individual interaction is measured. This means that the second estimate of the chain of charges is likely closer to the real value simply because it is capable of quantifying all of the individual interactions that the point charge model cannot.